So thanks everybody for dialing in, and thanks for Tanya for preparing this presentation about the PANGEA database, and also for swapping slots with Oliver, who couldn't make today. So thanks again for doing this earlier than anticipated. I mean, most of you know Tanya, but Tanya is a senior researcher in Christoph's group here in Oxford, and she's done everything. She's done microbiology, she's done bioinformatics, she's done computational biology, and at the moment she does the recency in infection work in PANGEA, and also at the same time looks after the PANGEA database to make sure that all your samples and all your data is kept in the right place. And Tanya has set up a specific database for PANGEA, a bespoke database. And well, yeah, today we're going to hear all about it. So Tanya, over to you.
Thanks, Lucy. That very comprehensive introduction. I don't actually do everything, but one of the things I do is design the data architecture for PANGEA and then sort of oversee it. And you may hear in this context either from me or from Laura Thompson in the group, who's one of the other data managers. So just kind of to introduce us. And what I thought I would do with this webinar is just talk about the idea behind the database, why it's constructed the way it is, how it's constructed, how it's managed, and then leave it up to you whether you want to know a little bit more about that or whether you've got specific questions. I'm going to try and keep it to sort of overview level, partly because there are a lot of know a lot about databases in general within PANGEA, and there are others who know almost nothing. So I'm going to try and strike a middle ground that will hopefully be of interest to all of you. I stole the title from a very bad movie. I apologize. It's complete clickbait, but it does actually come back in a little while, because we will talk a little bit about what we mean by samples. But first, I just want to give everybody a brief overview. I'm going to just touch on the data flow within PANGEA, so how the data actually moves around. For those of you who are impatient or in a big hurry to go and deal with something more pressing, like, I don't know, coronavirus, we're going to cover the essence of the PANGEA database in essentially one slide, and after that you're free to go. If you do want to stay and hear more, then I'll talk about it in a bit more detail. I'll cover how it's organized and this existential question of what is a sample. Then I'll specifically talk about what happens for those of you who send samples for sequencing, and also what happens conversely when you request data from PANGEA. And these may not be necessarily the same groups of people all the time, so there's different processes. And then we'll just summarize and leave it open for questions. So not a very full agenda, and should hopefully not take very long, leaving some time for us to just have a discussion. So first of all, the data flow within PANGEA begins with the study participants, as it should, and the members of the local communities. The data is collected by teams who, in this context, I'll just refer to as PANGEA investigators, and that obviously incorporates a lot of different groups sometimes with quite different ideas of how data is collected and managed locally. However, what joins us together is that we're all members of the PANGEA consortium, and the data that we collectively look at, generate, and process is stored in a PANGEA data hub here in Oxford. There are also PANGEA accredited researchers who are not necessarily PANGEA investigators, but who might be using PANGEA data for various research projects. They're all known to PANGEA and all approved by the steering committee, and they may get some data access which might be different from the full data access that you would get if you're a member of PANGEA. And also we look at releasing some data for open access, the non-sensitive data, particularly consensus genomes with some country and year of isolation information. And the idea is that this should be available to the research community and in some sense to the study participants as well. The bit I want to focus on today is the data hub itself. So that's the database, the team here in Oxford, what we do and how we store it and how we share data in and out. So here is this famous one slide. The PANGEA database, which is catchily called PANGEA database, is a relational database, MySQL, if you're interested. What that actually means, though, is that there are rows of related bits of information or records which are grouped into tables, and together they make up a schema. So if you've ever seen an Excel spreadsheet, that's great. You've seen a table. That is a table in the sense it's a one-table database. In an Excel spreadsheet, you may have rows which here are labeled by something unique, in this case just a number, 1, 2, 3, 4, 5. You can think of that as the primary key, so that's a unique identifier, identifies a record, and here there are some columns. And here there might be some information related to A, to B, to C, to D. So the columns are fields, and they each have a label. The rows are records, and they each have a label as well. And these are the primary keys. You might want to link them together. So for example, you might have some information about an interesting object, and then you might pack those objects into a box. You might want to have some information about the box. If you had that situation, you would have a schema or a group of tables, and the tables are linked together by these primary keys. That is basically it. That's true of any relational database. That's nothing special about PANGEA here, but it's just to give you an idea of how spreadsheets relate to databases, which is a question that often comes up, and it's a question that we've had again and again before. So I just want to specifically touch on that. In PANGEA, what we are trying to do with the schema, and this is the overarching principle of the whole thing, what we're trying to do is follow the real life flow of information. So how information is created with participant data first. So who is a question you would ask yourself, and then you would find some time invariant individual data. In this case, it'll be anonymized, so it won't be their, NHS number, but it will be some identifier, some year of birth potentially, some other information that doesn't depend on time. This might then result in a number of time-dependent bits of information, so a visit, for example, a survey round, if you're doing annual survey rounds, that kind of thing. That might have some additional bits of information, and there may be multiple visits for a person. So here we're starting with one person, and that's going to many visits. There may only be one, that's fine, but the database allows for multiples. The data then flows from visit through to a biological specimen. And there you might have some information about what type of specimen it is, for example. So was it plasma, was it proviral? You might have more than one specimen taken at one visit, or you might have produced a type of specimen from another. You might have produced some proviral DNA from plasma, for example. Sorry, not from plasma, from blood. Each specimen will then produce at least one, but maybe many, barcoded tubes, so aliquots. So you've aliquoted a single sample into lots of tubes. And it's at this point that the PANGEA ID, which you may have seen, is generated. So just kind of to recap this bit, the PANGEA ID refers to the tube, which will also have a barcode, which the requesting lab will have generated and will know something about. This should link to a specimen, like a blood draw, which will have been taken on a particular visit at a particular date from a particular person. That flow of information ultimately results in some sequence data which we generate. And here there is additional complexity I'm not covering, because you may, again, have multiple sequences, you may have made different sequencing attempts with different technologies, for example, you may have raw reads, assembled genomes, and so on. That's kind of not that critical for the purposes of describing what's going on here. So again, the flow of information goes from person, through the time, through the biological specimen, through the tube, and ultimately gives a consensus genome. Okay, for those of you who are not that interested in the rest, this is all you really need to understand about the PANGEA database. That's it. For those of you who might be interested in a bit more detail, here it is. And I know at least some of you might possibly feel like that. So let's just go through it in a little more detail, one step at a time, and you'll see that it's actually the exact same thing that I just showed, just with a bit more text. So first of all, we have the participant table, and here we've got some information. It might relate to their ID, gender, year of birth, country, ethnicity, whether they're a particular key population as identified by the people conducting the study, whether they've ever had therapy, and so on. There are also some calculated fields. So these are fields you can sort of work out from other information. For example, the date when they had a first positive HIV test. And that obviously happened on some date, so there would have been a corresponding visit, but ultimately we can figure this out and for convenience's sake, place these with the participant information. We have the visit, which I described. Visit can actually be quite complex because you can have lots of different types of information collected at each visit. And to sort of keep that organized, what we've done is to split the different types of visits into what was done. So was there a change in their therapy? Did we have a CD4 count on that date? Did we have an HIV test or a recency assay? If so, what were the details? What were the details of that? What was the viral load? And one type of time-dependent information in particular is the specimen. So this is actually not that different from, say, CD4 count. The difference is that a biological specimen was actually produced, a blood draw. As a result, we can now produce some aliquots from that. We can aliquot out the specimen, and that will go to PANGEA. And as I mentioned, the PANGEA ID will be created at this level. And then we go into the genome. So we go into tables. You can see there's actually multiple tables here. But essentially, this is the genome sequence that will then be generated from this aliquot. And as an aside, quite an important aside, there are also cohorts. So people can be sort of aggregated. Participants can be aggregated in different ways into cohorts. And a participant could be multiple cohorts. We can model that. For the purposes of PANGEA, we usually don't, but in some cases it's essential. And the schema can support that. There are other sort of slight quirks to it as well, but essentially this is the database as it stands. This slightly weird question of what is a sample, it seems like it should be a really straightforward question. Of course, everybody knows what a sample is. The trouble is that everybody knows what a sample is, but everybody are different people. So if you're in the lab, or if you're a nurse, for example, going and collecting samples, you might think it's a blood draw. Well, of course it's a sample. So in PANGEA, we will say that's a specimen. What if what's in a tube? Well, I've sent you some samples. Where are my samples? What you're actually referring to in that case are aliquots. So something in the tube. So within a database, again, we'll call that an aliquot. And then if you're a bioinformatician, you might say, oh, we've got some samples here. Actually, what you mean are sequences. But for convenience sake, everybody sort of says sample. And what I really want to highlight here is that you need to think about who is saying the word sample and what it means. And because of this possible confusion, we thought quite hard about this, and we've tried to eliminate this confusion by breaking things down within PANGEA. So what you know, and again, you in this case might be a PANGEA collaborator who's sharing some data and getting some aliquot samples sequenced. What you know might look something like this. You might know something about the participants. You might know when they were visited or interacted with, what was done on those dates, where their blood was drawn or another specimen was collected, and how it was aliquoted. You may not know how it was aliquoted. That depends on the lab setup on site. But the idea is basically this is kind of the information that's available to you. This is the information that's available to the Oxford lab. I really want to highlight this because there's a lot of confusion about what happens when you send bits of information to PANGEA. Who's PANGEA? The Oxford lab is really predominantly interested in the physical aliquots, in the boxes, things that go in the freezer. So the Oxford lab will actually only see this. So when you ask the lab, where are my samples? You need to be aware that it might not be that straightforward for the lab to answer your question if the word sample refers to, for example, a specimen. What the bioinformaticians know will look something like this. So we will know something. We won't know the full lab information about those aliquots, but we'll know enough to know which ones yielded a good sequence, for example, and which ones didn't, and how many times they were sequenced with what technology and what the outcome was. PANGEA database gives us the whole picture. So once you can see the database, you can see an extract, you can see exactly what's going, what's linked to what. But it's just worth keeping in mind at what point in the process you're actually aware of this, at what point you know whether an aliquot exists, whether something's in the freezer or not, because the whole thing is quite dynamic and there is a flow of data. So what happens when you send us samples, aliquots? The very first thing that usually happens, and hopefully by now you can see why, is that the PANGEA team, so usually myself or Laura, will send you a data request which specifies the fields that we need and maybe others that we would like to have. And that's based on the current database schema. You can return those if that's what you would like as flat CSV files or, in a pinch, Excel sheets, although there are difficulties with dealing with Excel, or structured tables if you've got a structured database at the other end that we can easily incorporate information from. We can use this information once we have it to assign PANGEA IDs, and that allows us to confirm to the lab that we have information that we can go on with. And for new projects, if there are new fields that you're able to share with us, which is fantastic, we are absolutely happy to modify, extend the schema if we need to, or map those new fields onto existing fields to make sure that we can incorporate all the information that PANGEA partners are happy to share. The aliquots, though, so this is the data, and the aliquots are received by the lab. They rely on the shipment manifest to check that the aliquots are actually what the manifest says they are, and everything will be checked against the database to ensure that all the barcodes have matching data. Now, the barcode is something that the PANGEA partners will know about because this is how the aliquots were labeled and how the boxes were assembled in the first place. And this is an essential bit of information for us to be able to link everything together so we can see the whole picture. And I just want to highlight again that the participant data, this metadata, must exist in the database for us to proceed with sequencing, because if it doesn't, we can end up in an unfortunate situation, which is not unprecedented. This has happened in every large project ever, where samples might be sequenced, and then this question of what is a sample comes back to bite you because you realize that actually they may have come from the same blood draw or from the same person unintentionally and so on. So we really would like to try and keep this organized, and that's why we try and focus everything on the participant information and the time. So conceptually it looks like this. We've got the PANGEA partner sending a shipment manifest to the lab with just the identifiers of the tubes, the aliquots, and we've got the data team receiving the data about the participants and the visits and so on that relate to these aliquots. And we put everything together using the aliquot ID and the signed PANGEA IDs. So to get back to the database, what happens when you request data? You may have seen this little box that I didn't point to before. These are our views over the database, and you can think of them as just predefined queries. These are things we've already told the database we frequently want to ask, and it just makes it more efficient to store some of these as predefined views. The default data sharing view is one of these, and that effectively combines some basic information from all of these different tables, or some of these different tables, to output something that looks like a spreadsheet. And those of you who've received data back from PANGEA know that that's what it tends to look like. It's a big CSV file. That is actually a combination of lots of different of fields from lots of different tables. So it's not a real table that exists. It's just a view. And PANGEA collaborators can, of course, request additional fields. So, for example, if you're interested in multiple sequences of the same aliquot, which normally you wouldn't necessarily be, you would just want the best one. But if you want to know if there have been multiple sequencing attempts, or you want a reverse mapping, you've got some sequences and you want to find out more about them, whether they've been deprecated, for example, by better sequences or not, these are things that we can help with in a more kind of bespoke way. So a simple data sharing example with lots of fields cut out to make it easy to see. Again, you can see this looks very much just like a normal spreadsheet. Nothing particularly unusual about it. We have some information. We have what has clearly come from the participant table, so some information about geography, some information about whether they have ever been on therapy, and some information which has clearly come from the genome table about the sequence, the quality of the sequence, the length of the genome at different cutoffs, the nearest reference from Los Alamos, from the Los Alamos HIV database, subtype, Shiva consensus, and so on. So, just to draw it all together, The PANGEA database is a relational database. It is in some sense very simple. The schema is made up of linked tables, which are made up of rows, same as any relational database. And you can think of each table as basically a spreadsheet about one particular kind of information with rows labeled by a primary key, which is the unique identifier, and that links everything together. We model the data flow as coming from the participant all the way through to the HIV genome. And what we normally return, if you just ask for some data from PANGEA, will be sort of the best sequence for each aliquot, for each specimen, for each visit, for each participant. And you can deduplicate to all of these different levels because we've made sure that we keep those things unique. And the basic principles are that we try and keep it as simple as possible, but we can build complexity if it's needed and as it's needed. We're trying to keep it real and focused on real physical things, which is a way of safeguarding against unintended duplication. And we're trying to keep it unique, so we allow for modeling of duplicates at every level intentionally, which will keep the data consistent. And as a final reminder, the shipment manifest is not a way of data sharing, it's just a way of allowing the lab to link their information with the entirety of the PANGEA database. So that's how everything fits together. And at this point, I'd quite like to stop and just take some questions.